electric potential energy of a system of charged particles. Let us consider three charged particles Q1, Q2 and Q3 are separated from each other at distances r12, r23 and r31 respectively. Now, in order to explain this, what I'm going to do, I'm going to use this information to draw a figure. So here's the figure where I have charges Q1, Q2 and Q3 and they are r12, r23 and r31 distance apart from each other. Then the total potential energy of the system is given as U is equal to U1 plus U2 plus U3, where U1 is the electric potential between Q1 and Q2, U2 is the electric potential between Q2 and Q3, and U3 is the electric potential between Q3 and Q1. And if we substitute the values, we will write U is equal to 1 over 4 pi epsilon 0 Q1 Q2 over R12 plus 1 over 4 pi epsilon 0 Q2 Q3 over R23 plus 1 over 4 pi epsilon 0 Q3 Q1 over R31. Now, you must be wondering what happens if you have more than 3 charged particles. So, let's consider a situation where we have n number of charged particles. So, we will write similarly, if we have n charged particles Q1, Q2, Q3 dash dash Qn are separated at distance r12, r23, r34 dash dash rn1 from each other respectively, then the total potential energy of the system is given as U is equal to 1 over 4 pi epsilon 0 Q1 Q2 over R12 plus 1 over 4 pi epsilon 0 Q2 Q3 over R23 plus dash 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 plus 1 over 4 pi epsilon 0 Qn Q1 over Rn1. And this is how we will define the electric potential energy of a system of charged particles.